the conservation of charge and equation of continuity. The law of conservation of charge states that the net amount of charge within an isolated system remains constant. If the charges decrease with time, the amount of charge must appear in some other region. This transport of charge constitutes a current. This means now if dq is the charge enclosed in a volume element given by this and leaving an elementary surface having area ds, we have I equals to closed surface integration of j ds. Let's call this one equation 1. This one will be equation 2. The total charge enclosed is given by the volume integration of the volume charge density. Now, let's call this one equation 3. In these equations, J is the current density and rho is the volume charge density, while this one is the volume element and this one is the area element. Now, having these three equations, from equation 1 and 2, if you look carefully, equation 1 and 2, we have current on both equations. So we can equate them. So we have the surface integration of J ds equals to minus dq over dt, and this one is our equation 4. Now, using equation 3 and 4, these two equations, if you look at them carefully, we can get the value of Q. We can substitute the value of Q, that is the charge. Therefore, we have the closed surface integration of J ds equals to minus, want to put this one right here, we are substituting the value of charge from this one. So we have minus the volume integral, then partial the volume charge density partial T times the volume element, and this will give us equation 5. From Gauss's divergence theorem, which relates surface integral of a vector function, say A, to its volume integral. So we have this one right here is the Gauss's divergence theorem. Now, using this one, we can transform this part of the equation from surface integral to volume integral. Therefore, we have the volume integral of divergence of A. In this case, we don't use A, we use the divergence of J. Instead of ds, we use the volume element equals to minus the integral of the volume element partial rho partial t, then we have the volume element. Now, if you look at this equation, it reduces to divergence of J equals to minus partial rho partial t. We can take this minus partial rho partial t to the other side. So we have divergence of J plus partial rho over partial t equals to 0. Now, we know that divergence of J can also be written as del dot J plus partial rho partial t equals to 0. This equation right here is the equation of continuity expressing the conservation of charge in differential form. This equation can be used to show that the differential form of Ampere's law, as obtained for steady currents, is incompatible with the principle of conservation of charge when the current is varying with time. Thank you for watching.